Welcome everyone. Myself Inam, starting this lecture with a finding. Have you ever think why area effective is not equal to the area net in tension member with holes? The answer lies in shear leg. This lecture will explore the concept of effective area, a powerful tool that goes beyond simple area reduction to account for shear leg and ensure safe and efficient tension member design. Effective area is the product of net area to the reduction factor. Net area is the gross area minus the area of holes. It will give the net area. When we multiply the net area with a reduction factor, it will give the effective area. Effective area is used to counter the shear leg. For shear leg understanding, consider an angle section and it is connected with only one side. This side is connected, so the other side is not connected. So due to this section is overloaded. It takes the load beyond the capacity, and this unconnected section is not overloaded, is not overstressed. So due to this, the phenomena occur shear leg. The uneven distribution occur in this member. To account this, we will use the effective area. Because the uneven distribution occur, this uneven distribution is called shear leg. Here you see that this is the connected element. Here the stresses are more, and the unconnected member the stresses are less. So we know that the connected member takes overloaded, becomes overloaded, and unconnected members are not fully stretched. In design, we will assume that all member takes even distribution of load, but in here it not take the equal distribution of load. The stresses are unequal. So here you see that this member is overloaded and this member is not overloaded. So this is uneven distribution of stresses. So this phenomena is called effective shear leg. To account in member, we will use effective area in fracture failure. Since we know that in tension member there are two types of failure. The one is excessive yielding and the another is fracture. So in fracture we will cover this. So here is the theory that when all elements of the cross section are not connected, then shear leg occur. Why occur? Because the connected element become overloaded and unconnected member is not fully stressed. This can be accounted for by using the reduced area or the effective area or net area. Since you know that the effective area is the product of reduction factor times the net area. In case of bolted connection, the formula will be same, that the effective area is equal to the net area multiplied by reduction factor. In case of welded connection, because in welded connection the gross area is equal to the net area, so the effective area will be the product of reduction factor times the gross area, means total area. In case of welding, we did not use the net area. If all the elements of the member of the cross section are connected, then we will use the reduction factor U equal to 1. Why? Because the shear leg are not occur in this type of member when all the cross section are connected with another member. Remember, this is the main point of the effective area. Here is the formula for the effective area, which is equal to the net area times the reduction factor. So we will calculate the net area by subtracting the gross area from the by subtracting the area of holes from the gross area. So how we will calculate the reduction factor? So for reduction factor we have 5 categories. The first category is that the tension member. The first category is that the tension members, all the tension members, remember this, except plates and round hollow structure sheet with the connection length greater than or equal to 1.3 times of the diameter. This is the number first category for calculation of U. So all the connection member means single angle, double angle, W shape, S shape, except plates means rectangular fill-up bar and the hollow structure seal, which is the connection length greater than or equal to 1.3 times. For this, how we will finding the U, we will cover in this lecture. For the remaining four categories, we will cover in the next lecture. For plates, what will be the value for U? For round HSS with connection length greater than or equal to 1.3 times of diameter, and the remaining two are the alternative values for the single angle, double angle, W shape, miscellaneous shape. For these we have some alternative. It's up to you that whether you use this alternative or for this calculation. So in this lecture we will only be discussing about this, that for tension member, except plates and hollow structure round HSS bar. So the first category is that for all tension member. All tension member include the angle shape, S shape, W shape, except plates, and this is the very important. From this we know that without this we are using this equation, means for all tension member except plates, round hollow structure steel with connection length greater than or equal to 1.3 times of the diameter. So we will use the nice formula that U is equal to 1 minus X bar divided by the L. X bar is the distance from this plane of connection to the centroid of the area. So this horizontal distance will be known as X bar. So here the X bar will be this, that this connection length to the area of the centroid, this distance will be the X bar. X bar can be calculated from manual directly. We cannot use any calculation here. We will use the manual, steel manual. Here select the type of the section as per the question, then move in front of this. We have these properties, section properties, that are the moment of inertia, sectional modulus, radius of gyration, and X bar. So here X bar will be this. From this table we will take the value for the X bar. And what is L in the formula? L is the connection length. Remember, this is in the direction of the load. What will be the connection length? Here consider this is a member and here it's the bolted connection. So if the load is applied in this direction, then the connection length will be the center of this bolt to the center of this bolt. This will be the connection length, not only the entire length, the connection length only. The direction of load. So by putting the values of X bar and L in this formula, we will get the value for U. So you get the value of U, just multiply U with the net area in case of bolted connection. In case of welded connection, multiply with gross area. So it will yield the effective area. So this was the today's lecture. We covered only one category for finding U. In next lecture we will covering all remaining 4 categories for finding U. Thanks to everyone. Allah Hafiz.